Wessex Water and aeration optimization. So, Wessex Water, we first got introduced to Wessex, our local manufacturer's representative, so a company called QCL, an individual there called Mark Watton. Myself and Mark drove down to Wessex Water. We connected with the chap Ivor Whittle. Ivor Whittle is the process optimization specialist for Wessex Water. And it was literally just like today when we started. We presented the technology 5-6 minutes. This is what it does. This is how it works. What are the problem statements that you have within your organization? What are the treatment facilities where you think this would be a good fit? And instantly, Ivor had a really good candidate for us, and it was a very interesting facility. So it was a wastewater treatment plant that had, a lot of traditional municipal wastewater coming in, but also had one key industrial discharger. It was a food production or a food processing type facility. And they were discharging big slugs of BOD and COD, but not always the same quality, not always the same volume, maybe not even always the same time of year. So it was very difficult for Ivor and at this facility to understand and basically optimize his own process downstream of that. The other interesting thing about this one is the type of organics that was coming down the pipe was very short, like very sugary type water or waste stream. So not very difficult for a UV type sensor to pick that up. If the organics are too small, if they're sugar based almost, if they're not large complex carbon based compounds, then it's sometimes very difficult for the traditional COD light based sensors to pick it up. So the question we wanted to test with Ivor was, could the SENTRY platform, could a bio-electrode sensor provide an in situ reading before the aeration basins that could provide a feed forward signal to those aeration basins to tell them when to expect additional BOD or additional demand on the biology. And then also as a secondary goal, it was, can we actually profile for Ivor, what's coming into this plant? What are the actual triggers? Can we put some data and metrics behind what's coming in and how it's impacting the process? So I'll just briefly highlight the process here. So we provide the SENTRY system. It's a control panel, and then the sensors were literally lowered into the wastewater. So there's no moving parts. You just let the sensors sit in the wastewater, and they're installed in about 4 hours. And at this site, we do visual inspection of the sensors about every 3 months. And with that, Jack, will I hand it over to you and you can talk about the project?
Yeah, that sounds good. Thanks, Pat. Yeah, and just so you can see a little bit of a PFD on the bottom here, or just the overview of the plant. They're a complicated plant. They have, multiple process streams that they can bounce wastewater through. Primarily, basically, there's a BAF system, biologically activated flooded filter, and a traditional ASB lane and a high purity oxygen lane. And the majority of the industrial stuff, they're trying to push through the high purity oxygen, with the other systems kind of collecting the rest of a little bit of the industrial and a lot of the municipal wastewater. And for them, they were really trying to target these BAF systems. They're a little abnormal, maybe not super standard for the wastewater industry. Very interesting technology. Basically does biological treatment and physical filtration in the same step, so you don't need a secondary clarifier after it. Has a lot of small beads in it that you upflow water through. So really good piece of equipment. Just I guess it's very energy intensive, very maintenance intensive, and they have 5 of these systems kind of running simultaneously and trying to figure out when they can bring one offline, or potentially up to 2 offline, is really where they're trying to get to, and the most important part for that is understanding their influent conditions. So it was it's been a really great working with the Wessex team and the QCL team, as Patrick mentioned. Very open to innovation, very much trying to improve their performance at facility. Also, very open-minded. Worked with us, got us some additional extra data, which was very helpful, both in BOD sampling and connected up to that light-based measurement. But you can see, show you some of the results. We're looking in the top left here. You can see some good trending with the BOD data and the MET data. MET being the blue data, and obviously that's a lot. Even with frequent sampling at a facility, even a couple times in a day throughout the day, you still have to fill in the lines between. Whereas obviously with the SENTRY signal, you get constant data through that. We did pick up 21 imbalance events. That was over about a 3-month period. That's just a snapshot. A number of those were associated with I&I, but also picking up this industrial discharge that, as Patrick was saying, our sensor responds quite happily to some of these, simple sugar, low chain carbon compounds, where some of the other sensors don't respond well to those. So we were able to kind of keep that detection up. And then one of the interesting things for almost all of our clients, and this is something when you finally get real quality, instantaneous data, is you're pulling a lot of pieces together. For them, they were really able to tell them, what days of the week were the high loads coming in, what time periods of the day. And it's always a bit of a surprise for people. They all have their kind of thoughts on it, and there's obviously industry standard about when you think that's going to happen. But for them, you can see the bottom left-hand graph. Sunday, they were underloaded. Wednesday, they were kind of higher loaded. Thursday, Saturday, kind of underloaded. And for them, their kind of lowest time period of loading to the system was typically 12 to 3 p.m. On a given day. So this really lets them figure out when are the opportunities for cost savings here. If you go to the next slide there, Pat. And just a little more information. This is about £500,000 per year for energy, requirements. So we're hoping to get a 10 to 20% energy savings through this usage. And you can see in the bottom right a little bit of the data from the optical SENTRY signal and DO sensors. Essentially, spikes up in our data, in the COD and SENTRY data, decreases in DO and vice versa. So you can really see how a slug moving through changes that aeration basin. Thank you, Pat.
Fantastic. Thank you, Jack. Okay. So Wessex is fantastic. So that's one for the aeration optimization people. And then again, looking at that providing that feed forward signal from a location before the aeration basins and being able to inform or help the DO get to its set points more accurately, and maybe providing that early warning for those load changes.